Okay, join everyone. So just wait 1 minute, then we'll continue. So last we have to prove. I am written the previous some line. That is a Z transform of y of k minus y of k minus 1. This is of Z transform of another part, that is x of k. Now we have to written these equations, that is y of z minus z inverse y of z. This is also that is x. Now yz, it is common from here, that is the rest of the part 1 minus z inverse is equal to x of z. Now we have to read, that is the y of z is equal to 1 by 1 minus z inverse into x of z. Okay, where that is x of z is equal to z transform of x of z. Okay, so these are short type of problem. It is coming in your exam. Okay, so please remember these problems also. Various types of problems are solved. So please everyone practice from the books or anyone any the online platform in Google you have to present. There are different types of problems. Okay, so please practice in your room. Okay, so next theorem. This is the basically another one, complex translations theorem. So here are different types of problems. Their properties are coming, or theorem it is coming. Okay. So these are the little bit some small type of question is coming in your sentence semester questions. What is initial value theorem, final value theorem, complex translation theorem. So now this is another important complex translation theorem. What is the theorem? If everyone note down, x of t, it has the Z transform of, that is xz, we know that, then the Z transform of e to the power minus at. We have solved in previously from the table e to the power functions, that is e to the power minus of at xt. It can be given by the function is x of z e to the power at. This is known as the complex translation. Complex translations theory. तो ये थ्योरी आप लोगों को याद रखना पड़ेगा, स्टेटमेंट जैसा है आप लोगों को लिखना पड़ेगा. So the complex translation theorem, if xt it is has the z transform, that is we know that x of z, then the z transform of e to the power at xt is can be given by x of z e to the power at. This is basically called the complex translations theorem. So here you can see this is a basically multiplication property you have to attach here. One is the polynomial function it is attached here, and complex functions it is attached here. So this was the basically called the complex transformations theorem. So what is the mathematical form of this complex transformation theorem? I am written here mathematical form, that is a Z transform of e to the power minus at x of t. This is equal to summation of k is equal to 0 to infinite x of kt e to the power minus akt z inverse. And next one, this is also summation of k is equal to 0 to infinite x of kt into z to the power, sorry, not minus, that is a z into z e to the power a capital T to the power minus k. And we have to return this equation x of z into a to the power. So this is another functions number. I think previously that is a 5, that is also 6 also. Okay, that is a z transform of e to the power at x. Okay, so this is the basically mathematical functions or mathematical form of the complex translations form. So using this complex translation theorem, you have to prove that is sine omega, matlab z transform of sine omega t or z transform of cos omega t. Okay, so previous tables we have to return the z transform table using the sine omega t functions or cos omega t functions. Okay, is it clear all of you? This is a complex translation theorem. I am proved this one. Another examples you have to give him. Then you have to clearly idea is given. So examples. 1 minute. Examples is given problem is given the Z transform of sine omega t and cos omega t, obtain Z transform of e to the power minus at sine omega t and e to the power minus at, sorry, this is cos omega t respectively by using the complex translation theorem. ऐसे आप लोगों को क्वेश्चन दिया जाएगा. ओके, either statement it is coming or sometime it is problem it is given. Okay, so question, पहले question को पढ़ो. Given the jet transform of the sin omega t and cos omega. Okay, so you know the table. From the table I am again and again telling, मतलब दिन का जब भी मतलब पढ़ाई का स्टार्ट करोगे, ये जेट ट्रांसफॉर्म का जो टेबल है, ये टेबल आप लोगों को एक बार मतलब आदत करना होगा, मतलब याद करना होगा. ओके, मतलब एक बार सुबह शाम एक बार वो टेबल को आप लोगों को देखना पड़ेगा, क्योंकि ये टेबल में हर एक फंक्शन का कैसे कैसे जेट ट्रांसफॉर्म का मतलब एप्लीकेशन होगा, वो आप लोगों को याद रखना चाहिए. तो यहाँ पे देखो, आप लोगों को साइन ओमेगा टी एंड कॉस ओमेगा टी का जेट ट्रांसफॉर्म को दिया गया है फ्रॉम द टेबल. ऑब्टेन द जेट ट्रांसफॉर्म, द फंक्शन इज e टू द पावर माइनस at into sin omega t, and also you have to verify e to the power minus at cos omega t. Okay, using only complex transformation theorem. Okay, now what I have to do? Answer. So first of all, we have to know the jet transform of sin omega t from the table, jet transform table. What is the functions? That is what is the answer? You know that is z inverse sin omega into capital T divided by 1 minus 2z inverse cos omega t plus z inverse 2. ओके, मतलब ये टेबल से हम लोग लिख सकते हैं यूजिंग द टेबल. Those who have written the previous table in the physical mode class, so please go through the table. So this is the basically jet transform of sin omega t. This is the answers. Now we substitute z into e to the power at for z to obtain the jet transform of e to the power minus at sin omega t. ओके, मतलब हम लोग क्या करेंगे, z e to the power at for the jet transform we have to obtain this function. So now the function is written, that is jet transform of e to the power minus at sin omega t, that is the function is e to the power minus at z inverse sin omega t divided by 1 minus 2 into e to the power at z inverse cos omega t plus e to the power 2 into at z inverse t. Okay, so this is the basically functions for the jet transform e to the power minus at into sin omega. Okay, this is basically sinusoidal form functions of the jet transform. Another form, I am going to the next page. This is clearly you have to written. Similarly, I am uploaded the jet transform table again from your the Google Classroom portal. Okay, so everyone read this table, jet transform table. This is very important. So similarly for the cosine function, we have that is jet transform of cos omega t. So using the table, we have to retain the functions of the jet transform of cos omega t. You know that is 1 minus z inverse cos omega t by 1 minus 2 z inverse cos omega t plus z inverse. Using table, we have to retain. Okay, now by substituting Z into e to the power at for the Z transform in the Z transform of cos omega t. We have that is a Z transform of e to the power minus at cos omega t. This is 1 minus e to the power a minus of at z inverse cos omega t by 1 minus 2 into e to the power minus of at z inverse cos omega t plus that is e to the power minus 2at z inverse. ओके सो ये आप लोगों को याद रखना पड़ेगा. सो मैं आज जो टेबल आप लोगों को अपलोड कर दूंगा ये भी एक फंक्शंस मतलब ये भी एक फॉर्मूला है उस टेबल में. ठीक है, ये टेबल में ये भी मतलब मैं जेड पहले दिन में जेड जेड ट्रांसफॉर्म ऑफ cos ओमेगा टी एंड जेड ट्रांसफॉर्म ऑफ sin ओमेगा टी वी हैव टू सॉल्व इन द टेबल. बट ये भी एक फॉर्मूला है जेड टू द पावर e टू द पावर माइनस at sin ओमेगा टी. अनदर वन इज द cos कोसाइन फंक्शन. तो ये आप लोगों को याद रखना. ओके, इज इट ओके? Now, another part. Please respond me, is it okay or not? Am I audible?
Yes, sir.
Yes, sir.
Okay. So please everyone write your name and roll number in the chat box also again. Next questions or next point. This is very important. Initial value theorem.
सर हम लोग का 12 बजे से क्लास है सर.
ओके, तो इसलिए तो मैं पहले पूछ रहा था 12 बजे से आप लोगों के पास मतलब कोई क्लास है या नहीं है. ठीक है, कोशिश कर रहे हैं. ये लास्ट जो टर्म है इसको खत्म करते हैं. छोड़. सो इनिशियल वैल्यू थ्योरम. So initial value theorem. So this is another functions of the Z transform method. The statement is if xt has the Z transform of that is xz and if limit z tends to infinite that is x of z it exists, then the initial value that is x of 0 of x of t, or sometimes it is also written x of k is given by that is x of 0, this is equal to limit z tends to infinity x of z. Okay, so this is the basically initial value theorem, that is when x of 0 the limit it is also a z transform that is z is equal to infinity range. So value is coming that is to prove this theorem. note that is x of z is equal to summation of k is equal to 0 to infinity x of k z to the power minus k. So you have to put the value different, that is k is equal to 0, k is equal to 1, k is equal to 2, and so on. So value is coming first k is equal to 0, that means here 0, that is x of 0. Then k is equal to 1, that is x of 1 z inverse, plus next is x of 2 z inverse 2, and so on, dot dot dot. So this is the basically called the initial value here. Okay, is it okay all of you?
Yes, sir.
ये भी आप लोगों को इम्पोर्टेंट है जेट ट्रांसफॉर्म का. ओके, सो आप लोगों का तो क्लास चल रहा है. ठीक है, कौन टीचर का क्लास है अभी?
Sir, Raju sir.
राजू सर का.
Okay, Pranav, you take a screenshot again, and then after ending the class you have to send me. And everyone please write your own name and roll number in the chat box also. एक मिनट रुको, मैं राजू सर को थोड़ा सा 10 मिनट के लिए टाइम ले रहा हूँ. ओके, सो यहाँ से भी एक प्रॉब्लम, मतलब प्रॉब्लम देख लो. अच्छा, राजू सर को मैं बोल दिया हूँ 10-15 मिनट के बाद स्टार्ट करेंगे. तब तक के लिए मतलब ये एग्जांपल देख लेते हैं. सो एग्जांपल्स फॉर द इनिशियल वैल्यू theorem. Question is determine the initial value that is x of 0 if the z transform of x of t given by, that is x of z, this is equal to 1 minus e to the power minus of t z inverse by 1 minus z inverse by into 1 minus e to the power minus t z inverse. Okay, so this type of problem you have to given, and you have to solve the problem using the initial value theorem. Okay, now what have to do? We have to apply the rules of the initial value theorem. So by using the initial value theorem, we find that is x of 0 is equal to the limit here z tends to infinite. We know from the rules, that is from the theorem, that is also 1 minus e to the power minus t z inverse by 1 minus z inverse into 1 minus e to the power minus t z inverse. Okay, so now you have to put the value, that is z tends to infinite. That means you have to put the value z tends to 0, then 1, that is higher level of the value is infinite. So value is also changes, because you know that this is a basically exponential functions, and this is the e to the power minus t. So the function is given, the result, that is also 0. Okay, so that's why this x of z of the transformation of the initial value theorem, that is xt is equal to 1 minus e to the power minus t. Thus, that is x of 0, this is also 0, which is the initial value theorem we have here. So this, if xt it has z transform of the xz, the limit it is also xz, the initial value theorem, either it is x is equal to 0 or x of the k, that is the k value changes. Okay, k is 0, 1, 2, 3, 4, and so on. This process is continuing. So this is basically called the initial value. Last property, that is the final value theorem. Last is final value theorem. ये सेमिस्टर में आप लोगों को मतलब छोटा छोटा क्वेश्चन करके भी आ सकता है, या बड़ा वाला क्वेश्चन भी आ सकता है. वैसे स्टेट द फाइनल वैल्यू थ्योरम ऑफ द जेट ट्रांसफॉर्म, स्टेट द कॉम्प्लेक्स ट्रांसलेशन थ्योरम ऑफ द जेट ट्रांसफॉर्म, ऐसे भी आ सकता है. और ऐसे भी आ सकता है राइट द डिफरेंट प्रॉपर्टीज ऑफ द जेट ट्रांसफॉर्म. तो तभी आप लोगों को बहुत सारे प्रॉपर्टी जो पहले दिन से पढ़ रहे हैं, जैसे मल्टीप्लिकेशन प्रॉपर्टी, लीनियरिटी प्रॉपर्टी, पॉलिनोमियल प्रॉपर्टी, okay, that is final value theorem, initial value theorem, or complex transformation theorem. These are the different properties of the J transform. So last, that is the final value theorem. Suppose that is x of k, where xk, when it is 0 or k is less than 0, as the Z transform that is xz, and that all the poles of xz is lies inside the unit circle, inside the unit circle with the possible exceptions of a simple pole at z is equal to 1. Then the final value of xk, that is the value of xk as k approaches infinity. So it can be given or it can be written as that is limit k tends to infinity x of k, that is limit z tends to 1, function is 1 minus z inverse into subject. Okay, this is another number of theorem final value. So to prove the final value theorem, note that is z transform of x of k, this is equal to x of z, that is summation of, this is summation, k is equal to 0 to infinity x of k z to the power minus 2. That means, just wait. That is z transform of x of another function k minus 1. This is z minus 1 x of z. This is the function, that is summation of k is equal to 0 to infinity x of k minus 1 z to the power minus 1. Two functions. First one is x of k minus 1, another one is the x of k. So hence first is summation of k is equal to 0 to infinity x of k z inverse k minus another one, that is this functions x k is equal to 0 to infinity x of k minus 1 into z to the power minus. So value is coming, that is first is x of z, another one z inverse x of z. Okay. Now taking the limit in the both sides, taking the limit as z approaches unity, we have, that is the limit z tends to 1, summation of is equal to 0 to infinity x of k z inverse k. These functions you have to return. Another one, it is also summation of k is equal to 0 to infinity x of k into minus 1 z inverse. Another, this side also you have to apply, that is limit z tends to 1, that is 1 minus z inverse into x of z. So you have to put it the value of this z tends to 1 into these functions also. The value is changes also again and again. The finally value is coming limit k tends to infinity. We have to retain the final equations. Sorry for that. X of k, this is equal to limit z tends to 1, 1 minus z inverse into x of, that is x. Okay, so this is the basic equations for the final value. Okay, so next class we have to continue of the another part. Okay, the time is ended and your sad is waiting. Okay, so thanks everyone. Okay, you all of you please leave.
Thank you, sir.
Okay. Can everyone write your name and roll number in the chat box also? Okay, so next class we have to conclude in the another part.